Before that, writing the program, just revise the basics for 5 minutes so that you can able to understand the program, or if you will be comfortable in the program. Okay, so just I will revise the theory part within 5 to 10 minutes. Okay, so serial communication in 8051 microcontroller. So basics of serial communication, you know that what is the difference between the serial communication and parallel communications? Already I've explained. So serial communication will be used for the longer transmission, and parallel transfer will be used for the shortest distance. Okay, so many um, advantages and disadvantages for the serial and parallel communication. So example is for the serial communication for mobile phone, and parallel communication is the shortest distance is printer, right? Okay. So another one is modem will be the serial communication. So modulator and demodulator. So bind whatever we are speaking, right, that will be converted, audio signal will be converted into binary zeros and ones. Then it will be transmitted. Similarly for the demodulator side, whatever the zeros and ones again that will be converted into audio, right? Yes. Okay. Serial data communication. There are two types. One is synchronous, another one is asynchronous communication. For synchronous communication, it transfers the block of data. In asynchronous communication, it transfers a single byte at a time. Okay. So device for the serial communication is one is UART, another one is USART. UART is universal synchronous receiver transmitter, and USART is universal synchronous asynchronous receiver transmitter. So these two devices will be used. For 8051 microcontroller, we are going to use for the UART communication. UART communication, universal asynchronous receiver transmitter. Okay. Some noise is coming. Please mute your system. Want me to check who is doing? Gautam. That's what I don't want to do this. Okay, now I will remove this. That is lock the room. Okay. So types of serial communication. So this we discussed, right. One is simplex, another one is off duplex, and last one is full duplex. So simplex means it's a one-way transmission, right? Example is printer. Off duplex is transmitter can able to transmit the data. Uh, in the receiver side also can able to transmit the data, but not both at the time, right? So example is walkie-talkie. In the walkie-talkie, you know that one person can communicate, another person will be receiving. If you want the receiver person to transmit the data again, he can able to do, but the transmitter section has to be received, right? So this will be uh, either one person can be transmitter, another person will be receiver, but both the way it can able to possible. Example is walkie-talkie. The last one is full duplex, or transmitter and receiver both can able to transmit and receive the data. Example is in the mobile phone, right? You know, okay. Asynchronous serial communication data can. So protocol, what is mean protocol? Protocol is nothing but a set of rules that will be agreed by both the transmitter as well as receiver. How the data will be packed and what is the size of the data. Before the data, we need to send some signal to identify whether the data you are going to transmit or like that. Okay, so protocol is nothing but it is a set of rules. Okay, so how many bits you are going to be sent like that when the data begins and ends. Okay, so data framing here, data framing first. I'm going to send the start bit to the receiver. Okay, so the receiver will understand that okay, hereafter data is going to come. Okay, from the start bit always should be low. Okay, start bit always should be low. From the receiver can understand when the low signal comes, oh, the data is going to be transmit like that. Okay, so remaining the D0 to D7 will be the data, and the last bit will be the stop bit, and the stop bit will be always high. This is the rules will be followed in the asynchronous serial communication. Okay, so first bit will be start bit, followed the start bit D0 to D7, 8 bit will be used for the data, and the 10th bit will be stop bit. Okay, so start bit is always low and stop bit will be always high. So this is the data framing structure or format of the asynchronous serial communication. Okay. What is mean by data transfer rate? You know that baud rate or baud rate. The data at which speed will be transmitted is called as baud rate, right? So we know that the data will be transmitting or downloading speed will be 1 megabits per second, or 3.3 or 250 6 kilobits per second, like that. That is what the data will be, how much speed it will be transferred. I can say that the number of bits can change per second, right? That is also called as baud rate. Or number of signals also. Signal is nothing but zeros and ones, right? That is also I can able to say that baud rate. Simply you can say what is mean by baud rate. Baud rate is the number of speed at which the data is transmitted. Okay, the number of signal changes per second. Next one is RS-232 is standard. So to allow the compatibility among the data or communication equipment. Okay, this RS-232 is mostly widely used for the serial input-output interfacing standard. Okay, you might have seen your computer or laptop. This DB RS-232 will be there. The DB25 pin will be there, or DB9 pin will be there. Okay. That will be used for the communication purpose. Okay. One more IC we are going to use here for the MAX 232 IC. What is the purpose of this MAX 232 IC means? This will be used for just converting the signals, because your 8051 microcontroller it will understand only zeros and ones, right? So here the signal levels are zeros and ones. But what about here RS-232 will be the signal level will be different. If it is 1, then -3 to -25 volt. If it is a 0, then +3 to +25 volt, right? So making -3 to +3 will be undefined. So here the signal level in the microcontroller is 0 means 0 volt, 1 means 5 volt. What about here? 1 means -3 to -25 in the RS-232 communication. So the signal level will be different from your system as well as your uh, microcontroller. So that the MAX 232 will convert vice versa, right? So microcontroller signal will be like TTL logic, right? Here RS-232 logic will be different voltage level. So it will convert the voltage levels vice versa. That is the purpose of using the MAX 232 IC. Okay. Okay, the next one is to calculate the baud rate. We discussed already in theory classes. So one more time we will say with XTAL equal to 11.0592 MHz, find the TH1 value needed to load the following baud rate. Please understand this how to calculate the baud rate. This is very simple. If you have the calculator, you can check it also. Okay. Otherwise, you can follow what I'm telling you. Okay. The first one is 9600 baud rate is given. Okay. To calculate baud rate, this formula you should use. The machine cycle frequency of 8051 is connected 11.0592 megahertz. So that will be divided by 12 for the first step. Already we used this further in the timer configuration also. Okay. So if you use the XTAL is nothing but the crystal frequency or crystal oscillator is connected to the microcontroller. So 11.0592 divided by 12, you will get 9 to 1.6 kilohertz, right? For we are going to use the UART communication, right? That's what I told you that we are going to use the UART communication. What is that UART? Universal Asynchronous Receiver Transmitter, right? Okay, for this one, you have to divide the frequency by 32. Okay, so if you divide 9 to 1.6 kilo, this is the constant value by 32. Okay, when you are going to use the UART IC, you should divide the frequency 9 to 1.6 kilohertz divided by 32. You will get 28,800 hertz. Okay, this is the value you are. Okay, Okay, next step. To set the baud rate, now is 28,800 divided by, I need 9,600 baud rate. So what is the value I should load to the timer? So 28,800 divided by 9,600. What is the value you will get? I will divide here 28,800 divided by 9,600. You will get 3. You will get 3. Okay. You will get 3. That's what this step. Okay. So this 3 value you have to subtract with 256. Suppose, for example, if you are using the uh, mode 2, mode 2 operation is 8-bit. Okay, so 256, the maximum value is 256 minus 3, you will get 253. This 253 you can convert into hexadecimal number, you will get 253, you can convert into hexadecimal number, then you will get the hexadecimal value is FD. That's what this one, FD. Okay, if you didn't understand this minus 3 how it comes, okay, forget about this minus 3 right now. Okay, to 28,800 how it comes, you understood, right? That value divided by 9,600 baud rate, it will give the value of 3. Okay, this 3, if you want to use timer 1, so what value you should load? Timer 1 means the value will be 65,500 and 65,536 minus 3, you will get 65,533. This value you should convert into hexadecimal, then upper value, that means the TH value will be loaded with FF and the TL value will be loaded with FD. If you use mode 2 operation, that is 8-bit, then you can load the value FD. Okay, so this 3 comes right. Okay, if you put directly minus 3, see this FD, if you convert this FD into 2's complement, you will get minus 3. Okay, it's vice versa. With the minus 3, you will, this minus 3, if you convert into 2's complement, you will get the value of FD. Okay, so whatever the value I'm getting here, just put minus 3, or you can convert into 2's complement value and substitute. The another method is this 3 value you can just subtract with the maximum count value minus this x value, then convert into hexadecimal, you will get FD. So any way you can use it. That's not a problem. I hope if you have any doubt in this, you can text me in WhatsApp or mail also. Then I will explain. Okay. So similarly, 28,800 means sorry, 2000 baud rate, 2400 baud rate means 12. So minus 12 you can load. Similarly for the next one is 1200 baud rate means minus 24 you can load, or E8 you can load. Okay. So TH1 value for the different baud rates. So this is the formula, you should keep it in mind. The first one is crystal oscillator, which crystal oscillator we are connecting to the microcontroller, that should be divided by 10. Then again divided by 32, you will get the frequency. That frequency divided by how much baud rate you want. That will use the value of x value. That value you can subtract with the maximum count value. Then again convert into hexadecimal. You will get the baud rate value. Okay. Yes. So same values. SBUF register. This is very important. SBUF register is nothing but serial buffer register. What is mean by buffer? Just a storage, right? Okay. This serial buffer register is 8-bit register. This is used to whatever the data you want to transmit, you should initially load into the SBUF register. That is the main name of the SF register. Okay. So what the data you want to transmit, that should be loaded into the SBUF register. Okay. This SBUF register is a 8-bit register. Okay. For byte data to be transmitted via the TXD line must be placed in the SBUF register. That's it. I told you that must be placed in the SBUF register. The moment the byte is written into the SBUF, it is framed with the start and stop bit. Because we are seeing this asynchronous communication, we are going to use the 10 bit. First bit is start bit, following the start bit, 8 bit will be the data, and the last bit, 10th bit will be your stop bit. Okay, so it will automatically it will frame for the start and stop bit. Similarly, for the receiver side, it will eliminate the start bit and stop bit. It will understand only for the data from D0 to D7. Okay, so SBUF holds the byte of the data when it is received in the RxD line. Okay, this is the important point. When the bits are received serially via the receiver pin, the 8051 deframes it by eliminating the start and stop bit. That's what I told you, that it eliminates start and stop bit, making a byte out of them that are received, then placing the SBUF register. Okay. Next one is serial communication register, SCON register, control register. What is the purpose of these registers will be used? Uh, Here, mode of operations will be there, and the data will be transmitted to the multi-process communication, and the transmitter and receiver bits also is there. So, just we are going to see that how this will be used. This SM0 and SM1, these two bits will be used for the mode specifier. So in the mode specifier, you know that 2 to the power 2 is 4. So 4 combinations are there. Mostly in UART communication, we are going to use for the mode 1 operation. Mostly we are going to use for the mode 1 operation, that is 8-bit UART, right? 8-bit UART. Baud rate will be variable, right? Okay. So 0, 1 you should substitute here, 0 and 1. And what is this MS2 bit will be used for the enabling the multi-process communication. We are not going to use for the multi-process, we are going to use for the single process, so that SM2 also make it as 0. What is this REN pin? This REN pin will be set or cleared by the software, enable or disable the reception. What is mean by reception? We are going to receive the data, right? We should enable this particular bit to receive the data. So this REN pin should be made as 1, right? Then what is this TB8? This TB8 is 90-bit data will be transmitted. We are not using for the 90-bit data, and even this will be used for mode 2 and 3. We are not using the mode 2 and 3, so that this TN8 bit should be make it as 0. Similarly, RB 8-bit also make it as 0, because in mode 2 and 3 communications only it will be used. So that is also I'm not going to use. So make it as 0. This TI and RI, these two bits are these two these two bits are used for transmit the interrupt flag and receive the interrupt flag. So this is just to monitor whether the data will be received or not. Similarly, whether the data is transmitted or not. So make it as 0, these two bits. So if you configure this SCON register 0, 1, 0, 1. So what the value you will get? 5. Here all will be 0. So 50 you will get in the SCON register. So always you have to load the value of 50 H into the SCON register. Okay. That's it. We are going to write a program. Before writing the program, the steps will be followed. If you understand these steps, then writing the programs are very, very easy. Okay, serial programming the serial data transfer. Similarly, for timer operation, we followed some 7 steps. Right? Similarly, here also for transmitting the serial data, we are going to follow the 8 steps. The first step is load the TMOD register value. Okay, which timer you are going to use, which mode of operation you are going to use. Okay, so this will be first step. TMOD register is loaded with the value 20H, indicating the use of the timer 1 and mode 2. So why mode 2 will be used? It is auto reload mode. No need to load the value again. The second step will be load the TH1 value for the to set the baud rate value. Right. So baud rate value, we know that if it is a 9600 baud rate, then the value of -3 you have to load to the TH1, or you can load with FD, right? The third step will be SCON register value will be loaded with the 50H. Why this 50H? Just we discussed, right? Okay. Then start the timer. How to make the timer to start? If you are assembly language, you know that set bit TR1. Okay. Then TI bit will be cleared because if it previously some data are transmitted, then this bit will be high. So for that purpose only we are making again for the clearing the transmission interrupt bit. Then character byte. If I want to transmit the character byte, where I should move to the SBUF register. Okay. Once the data is transmitted, how to check whether the data is transmitted or not? By using the instruction is JNB TI. What is this TI? Transmission interrupt. This XX is nothing but here. If the data is not transmitted, then it will stay in the instruction itself. If the data is transmitted, then it will come out of the loop. So this JNB instruction is used for the polling method. I hope you understood what is meant by polling. Polling means microcontroller continuously monitor this data. What about the interrupt? Interrupt is nothing but when a device is required service, then it will give the command to the microcontroller. I hope you understood the difference between the interrupt and polling method. Okay. The next one is the last method or last steps will be transfer the next byte, go to the step number 5. This is the step number 5. Transmit this bit will be set as a 1 so that clear. Then this will be continuously. It will be right. We hope you understood the steps to be followed for the serial data transmission. I will repeat and I will tell you the shortest form. The first method is load the TMOD value, right? Second method is baud rate value you are going to load. Second one is configure the response register. That value is 58 should be loaded. Start the timer. Then what the data you are going to transmit that should be placed in the SBUF register. Then monitor the TI bit by using the JNB instruction. Okay. Then if you want to repeat the operation, then you can go to the step number 5. These are the steps you should follow the transmitting the data. Okay. We'll see the data program. Okay. Write a program for the 8051 to transfer a letter A serially at 4800 baud rate continuously. This program I am going to show the output. Okay, so be careful and listen step by step because once I completed, you are going to do the same program and your output window you should share to me. Okay, so clearly listen how to do this experiment. Okay. Write a program for the 8051 to transfer the letter A serially at 4800 baud rate continuously. What is the first step? So you know that what is the first step? Move the TMOD value, right? So move TMOD equal to 20H. This 20H is used for the timer 1 and mode 2. If you want to use timer 1 and mode 1 also, you can use it. That's according to your wish. Okay. Next. Uh, the baud rate is 4800. So what is the value? You should load to the TH1 minus 6. You can load, right? Okay. The next one is SCON register value should be loaded with 50 H. Okay. What is the next step? Start the timer. Which instruction is useful for starting the timer? Set bit TR1. Okay. What is the next step? What the data you are going to transmit that should be moved to the SBUF register. So here I'm going to load the data A or I'm going to transmit the data A. So that data A is moved to the SBUF register. What is the next step? JNB TI. What is the TI? Transmission interrupt bit. This will wait until the data is transmitted. Once the data is transmitted, then this bit will be set as a 1. What is the next step? Clear the TI. So clear the TI means then it is ready to transmit another data, right? So this process will be keep on doing right until I stop the program. So what is the next step? Should be as jump again. So again means it will go to here. So what the output you will get from this program continuously you will get until you stop the program. Okay. I hope you understood the program.
Tell something or else.
Okay, I'm going to show the output for this one. I'm going to show the output for this program. So only 3 minutes are left. After that, the meeting will be end because you know that only the 40 minutes will be the limitation. Okay. So again, I'm going to continue on the same meeting ID and the password. Okay. Um, okay. I will close the meeting. Then I will start. Please come again. We'll check it how many participants are there. Then only I will do the attendance. Okay. Only 3 minutes are left. After that, I will open once again. Okay. If you have any doubt, you can reply into the chat. This program I will execute in the PLC software. Please reply in the chat. No doubt, we can start with the program. That's good. Sangeetani. What about others? Shiva Prasad, Vishal, Shavardhan, Sri Darshini. I think Sri Darshini is there. Reply in chat. Shivangi, no doubt. Pavan has same ID. Within 1 minute, it is going to end it. I'm going to start again with the same ID. Then I will show the output in the KLC software. No, Vivek Ranjan. No doubt. Varun, you're there. Good. Understood the serial communication program. Vishnupriya. Vishnupriya, reply in chat. Understood the serial communication program. Okay, anyway, it is going to be end the meeting. Then I will restart again once again. Okay. Vishnupriya, reply in chat. Shivangi, Saranya, Harshvardhan, are you there?